So much of the air pollution we're going to look at in this little section is the air pollution that comes from cars and so on. So we have to think about what we're popping into the cars and what's coming out the other end. So most of this air pollution is coming from this. So we'll look at car exhaust gases. Contain the following pollutants. Obviously they also contain unreacted, they also contain carbon dioxide as well, because that's coming out. In addition to, well, we're going to have carbon dioxide coming out. That's what we looked at with the old global warming. What is another product of combustion? Carbon dioxide plus water, yeah, water. And also, we're also going to have unreacted oxygen and nitrogen gas that just gone straight through. So oxygen and nitrogen. So there's three we need to look at. So we do a little table. So we'll fill out this table. The pollutant, how it is formed in the car engine and why it causes us problems. So the first one we're going to look at is one that I'm sure you're familiar with from GCSE, and that is carbon monoxide. So you should be able to tell me, how is it formed?
Lack of oxygen.
Yeah, which we term as incomplete combustion. So it's formed by incomplete combustion. Occurring in your car engine. Why is it harmful?
Poison, toxic.
Yeah, it's toxic, yeah. It's particularly dangerous because it's a toxic gas, but if I was to get a cylinder of carbon monoxide and just let it off in this room, yeah, and odourless, you wouldn't know, what would happen to us? Well, we get carbon, what would be the symptom? How would we feel?
You go dizzy and oh, my friend got it.
Oh, okay.
He then kept taking him to hospital and put in this like chamber.
To oxygenate you, yeah.
Okay.
Yeah, you'd feel probably quite tired, you know, a little bit sleepy.
Drowsy.
Yeah. Why is it harmful? It's because it combines So it combines with the hemoglobin in our blood, which prevents it from carrying oxygen around the body.
Oh, so is it like join with the heme groups, so then there's no space for oxygen?
Yeah, that's right. Carrying oxygen. Yeah, we look at this at A2. It combines as an iron ion in hemoglobin, and it combines with that, and it stops that carrying oxygen around. So that's the first bad boy that we want to avoid coming into contact with. The next one we looked at a little bit. They are nitrogen oxides. Hey, do you think why nitrogen oxides formed in the car engine? Yeah, because it's really high temperature, high pressure in your car engine, so that's why. Because nitrogen and oxygen don't generally react. But when we talked about it, when we looked at ozone, that with lightning, that can get them to combine. So the car engine, very hot, high pressure, gets nitrogen and oxygen to combine to form nitrogen oxides. So this is formed by reaction of nitrogen and oxygen at high temperatures in the engine. Why is it harmful? This is like, it causes something called photochemical smog, which I'm not sure if you're aware of, which is actually quite an irritant to your lungs and so on.
That thing that kills fish.
Not generally fish, because they're in the water. I think that could be acid rain.
Is it the same chemistry GCSE? I think we did, yeah. And then it's not ozone. Stop. I'm trying to remember that.
So it causes formation of photochemical smog and low-level ozone. Now, we talked about how ozone is really good up in the upper atmosphere because it protects us from ultraviolet rays. It's not good for us to breathe. You don't want to be breathing ozone. So it causes low-level ozone, which causes respiratory problems. We'll talk a little bit more about that in a minute. And the final one, surprisingly, is actually unburned fuel that's coming out the end of the engine. So unburned hydrocarbons. So how is it formed? Well, the fuel does not react with oxygen in the engine. And that's not very good for us because often they're carcinogens which cause cancer. That's the chemical that causes cancer. So we'll say it's harmful because some cause cancer. Some of these unburnt hydrocarbons.
Okay.
Yeah. So how is photochemical smog caused? It's caused when, so photochemical smog and ozone. This is produced at ground level when sunlight interacts with nitrogen oxides in still air conditions. So you don't have much of a wind because the wind moves the air around, so it stops that happening. But if you get bright sunlight, the air's not moving around, so it's a very still day, and you have nitrogen oxides building up, then you get this photochemical smog kicking in. Where is that dangerous? So often what you'll find is, let's say, you've got a little valley, and here's your city in the valley, like so. So you have lots of cars, and that's producing. It's a nice, bright, sunny day. So the sun's. So you get cold air gets trapped, and then you have warm air up here. You know that cold air is denser than warm air, so it gets trapped here. So so the air isn't moving around. You may have the wind blowing there, but it's not going to move this air here. So you get stagnant air building up here. So all the cars driving around, and nitrogen oxide building up, bright sunny day. So you get all the build up of pollution in this air here, which you need to be able to get away from. So you often see that in large cities where it's got still air, you get this smog up here. Have you ever been to a city where you get the smog? It can be really, it's almost like a fog. You kind of feel it's like a foggy day, but it's actually just